In this video, we're going to talk about how to find the number of factors of an integer. For example, 2016. The fundamental approach for such problem is to do prime factorization. So let's first see how we do prime factorization for 2016. And we know that prime factorization is really a recursive process. Every step you're going to find out the minimum factor of the number, and you keep doing for the other factor. So for example, 2016, the minimum prime factor is 2. The other factor is 1008. For 1008, the minimum prime factor is again 2. This is 504. Keep doing that. 2, 252, 2, 126, 2, 63. Now for 63, it's not an even number anymore, but 3 is its prime factor. Left was 27, and then 3 and 7. 7 is a prime number, so you cannot do prime factorization further. So that left with 2016 in prime factorization form is 2 to the power 5 times 3 to the square times 7. So this is the prime factorization form of 2016. Now let's consider what makes a number a factor of 2016. So let's first focus on a simpler problem. What makes a number in the format of 2 to the power something a factor of 2016? I'm asking the question, what possibly, how many numbers of 2 to the power k is a factor of 2016? Now for this, I'm claiming 1 is definitely a factor of 2016. 2 to the power 1 is a factor. 2 to the power 2 is a factor. 2 to the power 3 is a factor. 2 to the power 4 and 2 to the power 5. Is 2 to the power 6 a factor? The answer is no. And you actually can see that if it's a factor, you can write 2016 equals 2 to the 6 times some integer k, correct? But on the left side, 2016, it only has power 2 to the 5 times 3 squared times 7. So in this, that's impossible because I can divide both sides by 2 to the 5. Left with left side is an odd number, but this side is going to have 2 times k, which is an even number. So that's impossible. 2006 is not a factor. So in terms of the forms of 2 to the power k, there are only 6 numbers in the form of 2 to the k. That is a factor of 2016. Similarly, in the form of 3 to the k, there are only 3 factors. 1, 3 to the power 1, 3 to the power 2. And for 7, there's only 2, 1 and 7. Now the interesting part. It turns out that all the factors of 2016 can be looked at a combination of these 3 different choices from 2 to the power something, 3 to the power something, and 7 to the power something. Actually, it turns out in every combination of these, so 1 times 1 times 1 is a factor, give you a factor of 1. 2 times 1 times 1 give you a factor of 2. 2 squared times 1 times 1 give you a factor of 4. And 1 times 3 times 1 give you a factor of 3. 1 times 3 times 7 give you a factor of 21. So all those different combinations, you have 6 choices here, 3 choices here, and 2 choices here, that all those different combination of those choices going to give you a factor. For example, 2 to the 4 times 3 times 7. That's 2 to the 4 times 3 times 7 is a factor of 2016. So the total number of factors will be equal 6 times 3 times 2, which is 36 factors. Where you get the 6, 3, and 2, really in this prime factorization, 2 to the 5, 3 to the square, 7, you have those exponent of this prime factorization 5, 2, 1. And you're going to adding 1 to each of the exponent. 5 plus 1 times 2 plus 1. That's the exponent for the 3 to the power 2. 2 plus 1 times 1 plus 1. And that's the number of factors for 2016, which is 36. A different way of saying what we just described here is, once you have the prime factorization of 2016 equals 2 to the 5 times 3 squared times 7 to the power 1. What are the potential forms of its factors? We claim the factors has to follow in this form. 2 to the power something here. Let's call it A. 3 to the power B. 7 to the power C. And where A has to be less than or equal to 5, B has to less than or equal to 2, C has to less than or equal to 1. And all of them are non-negative integers. So how many possible choices for A, how many choices B, and how many choices for C? And this is so-called the product principle. For A, there are 6 choices, because from 0 to 5 inclusive is 6 choices, times 3 choices for B, and times 2 choices for C. And that goes to 36. And that's the way to find the number of factors of 2016. In the next lecture, we're going to talk about the number of factors in its general form, and we're going to derive it in a more formal way.